10 years ago, almost nobody imagined NVIDIA would become one of the most valuable companies on Earth. Today, it's worth trillions of dollars, more than Apple, more than Google, more than almost anything on the planet. But its journey almost ended before it began, in a Denny's diner, with 3 engineers who had no money, no product, and no idea if any of it would work. This is the story of how a graphics chip company built for video games ended up powering the entire artificial intelligence revolution. The story starts in 1993. 3 engineers, Jensen Huang, Chris Malachowski, and Curtis Priem, met regularly at a Denny's in East San Jose to sketch out an idea. Huang was working at a chip company, Malachowski and Priem at Sun Microsystems. They all believed in the same bet, that computer graphics, not just processors, would become one of the defining technologies of the next decade. At the time, this was a niche idea. Personal computers were mostly used for spreadsheets and word processing. Video games existed, but 3D graphics were primitive, blocky, flat, slow. The 3 founders believed that gaming would demand more visual power than a regular processor could ever deliver, and that a specialized chip built only for graphics could unlock something new. They founded NVIDIA that same year. The name came from NVIDIA, the Latin word for envy, a nod to the ambition of building something every competitor would want. Getting funding wasn't easy. They pitched investors on a product that didn't exist yet, in a market that barely existed either. Eventually, they raised a small amount of venture capital, a fraction of what tech startups raise today, and got to work in a cramped office racing against bigger, better-funded competitors who were chasing the exact same idea. The vision was simple to describe and brutally hard to execute. Build a chip dedicated entirely to rendering graphics so the main processor could focus on everything else. It's a concept so standard today that every phone and laptop has one. In 1993, it was unproven. NVIDIA's first real product was a chip called the NV1, released in 1995. It was ambitious. It handled graphics, audio, and even had a game controller port built in. Sega, the video game giant, agreed to use it for a home version of their arcade hardware. It flopped. The NV1 used a technical approach, quadratic texture mapping, that almost nobody else in the industry adopted. Software developers weren't building for it. Microsoft was about to release DirectX, a new standard that worked completely differently. NVIDIA had bet on the wrong technical foundation, and the market was leaving them behind in real time. The company was burning through cash with no working relationship with the industry standard. Layoffs followed. By some later accounts, NVIDIA had roughly enough money left to last a few more weeks. Jensen Huang has talked publicly about how close the company came to simply disappearing. Not a dramatic movie-style near-death experience, but the quiet, grinding reality of a startup watching its runway disappear. The lesson that came out of that failure reshaped the company. NVIDIA committed to building around industry standards instead of fighting them, and to shipping fast, even if it meant admitting mistakes quickly. Their next chip, the Riva 128, launched in 1997, built on DirectX support and shipped in under a year. It sold over 1 million units and effectively saved the company. Then, in 1999, NVIDIA released the GeForce 256 and coined a new term for the industry, the GPU, or Graphics Processing Unit. That same year, the company went public on the NASDAQ. It wasn't yet a giant. It was a survivor that had learned the hard way how to bet correctly. For the next several years, NVIDIA grew by doing one thing extremely well, making graphics chips faster for video games. But the decision that would eventually define the company's future came in the mid-2000s, and almost nobody outside the company understood why they were doing it. A GPU is built differently from a normal computer processor. A regular processor, a CPU, is designed to handle a few complex tasks one after another very quickly. A GPU is built to handle thousands of simple tasks all at once, which is exactly what's needed to color in millions of pixels on a screen simultaneously. That structure, it turned out, was also useful for something far beyond gaming. Mathematics involving huge grids of numbers, the kind used in scientific simulations, physics, and, although almost nobody realized it yet, machine learning. In 2006, NVIDIA released something called CUDA, a software platform that let programmers use GPUs for general-purpose computing, not just graphics. This was a strange, expensive bet. CUDA cost the company enormous amounts of money in engineering and chip design for years, with very little commercial payoff at first. Wall Street didn't love it. For roughly a decade, NVIDIA's stock mostly moved sideways while the company kept funding a piece of software that most of its gaming customers never used. But a small number of researchers noticed something. Around 2012, a team using NVIDIA GPUs trained a neural network called AlexNet on a massive image recognition competition and beat every previous approach by a shocking margin. It turned out that the parallel structure built for rendering video game pixels was almost perfectly suited to training artificial intelligence. Deep learning researchers began buying NVIDIA GPUs by the truckload, not to play games, but to train algorithms. CUDA, the wasteful bet from 2006, had quietly become the foundation of an entirely new industry. NVIDIA didn't have to pivot into AI. AI came to them because they had already spent a decade building the tools that made it possible. NVIDIA's story is not really a story about chips. It's a story about a company that made an expensive, unpopular bet on an idea nobody else believed in yet, and stuck with it for over a decade before the world caught up. From a struggling startup with weeks of cash left, to the architecture behind the AI revolution, to the most valuable company on the planet, NVIDIA's rise raises an obvious question for anyone watching the technology industry right now. Can NVIDIA hold on to its lead? Or is a competitor already building the next unpopular bet that will define the decade after this one?